Stats students. Today we're going to be looking at section 1.3. So we've already just in 1.2 discussed how to display quantitative data in graphs. So we talked about dot plots, stem and leaf plots, and histograms, but now we're going to be looking at describing quantitative data with numbers. Okay. Our goals or objectives for this lesson, we're going to be able to calculate measures of center, which are the mean and the median. And we're going to calculate and interpret measures of spread, range, IQR, standard deviation. We're going to choose the appropriate measure of center and the spread in a given setting. We're going to identify outliers using the 1.5 IQR rule. And we're going to make and interpret box plots of quantitative data. We're going to use appropriate graphs and numerical summaries to compare distributions of quantitative variables. I might also say here that this lesson will be in two parts. So this is the entire learning objectives for both days of learning on this section. So we'll split this kind of in half here. So, all right, so with the first part, we're going to be looking at measuring the center, the mean. The most common measure of center is the ordinary arithmetic mean or arithmetic average. To find the mean, x bar is how we write that. It's with an x with a little line over it. That's called x bar. Of a set of observations, we add their values and divide by the number of observations. So if there are n observations, we add up all the x's, and their mean is the sum of the observations divided by n. So you add up each one of these x values, which is the different observations, and you divide by how many there are. In mathematics, the capital Greek letter sigma is short for add them all up. Therefore, the formula for the mean can be written in a more compact notation as x bar is equal to the sum of all the x's divided by how many there are, since there's n of those. Okay. Another common measure of center is the median. The median describes the midpoint of a distribution. The median is the midpoint of a distribution, the number such that half of the observations are smaller and the other half are larger. So to find the median of a distribution, we arrange them from smallest to largest, and if the number of observations is odd, the median is the center observation in the ordered list. And if the number of observations is in or even, then the median is the average of the two center observations in the ordered list. So we have a data set here. Let's use this data set to calculate the mean and the median. This is commuting times and minutes of 20 randomly selected New York workers. So to calculate the mean, we would add them all together. So we'll go down through here and add up all these numbers, and we'll divide by 20, which gives us to be about 31.25 minutes. That is your x bar, your mean. All right, so here's a stem and leaf plot here, and so if we want to get the median of that, we look for the most middle one. So what you kind of could do with this is, if you didn't want, I kind of like organizing it by just reordering the whole list up here instead of doing a stem and leaf plot. But if you do a stem and leaf plot, what you kind of do is just mark off the ones at a time. Mark off the first one and the last one, and then the new first one and the new last one, and keep going until you get to the middle, which in this case there's 20 and 25 both, because you got a 0 and a 5. There's an even number here, so you have to do the average of those two, which gives you about 22 and a half minutes. So that is the median in this case, as you mark them off. So like you would mark off 5, you would mark off 85, you'd mark off 10, you'd mark off 65, you'd mark off 15 and then 60, and 15 and 60, and 15 and 45, and you just keep going until you get to the very middle, which would be the 10th set, which would, if you know how many there are, there's 20. Let's think about this too this way. There's 20 observations here. We know that's an even number. We know that we could divide it up between 10 and 11. So go to the 10th one. So you count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Between the 10th and the 11th one is the median in this case. So it's the average of 20 and 25 there. And again, that's how you get that. So you can look at it that way too. Either way. All right, so the interquartile range, IQR. That's what that stands for. IQR, you're going to see me write IQR. You're going to see IQR written. It means the interquartile range. A measure of the center alone can be misleading. A useful numerical description of a distribution requires both a measure of center and a measure of spread. So how to calculate the quartiles and the IQR? To find the quartiles, you arrange the observations in increasing order and locate the median. The first quartile is the median of the observations located to the left of the median of the entire list. Okay, the third quartile is the median of the observations located to the right of the median of the entire list. So you find the median of the whole list, then you're going to find the median of the first half and the median of the second half, and that gives you your Q1 and Q3 in this case. Q2 is the overall median. That's why that one's kind of missing there, if you're wondering about that, why we go from Q1 to Q3. The second quartile is the median. And the IQR is going to be the Q3 minus Q1, whatever that quantity is. So you take the third quartile minus the first quartile, and that gives you the interquartile range. So here's our travel times for 20 New Yorkers. We put it in order, we get this list right here. We already know that the median is right here between 20 and 25. Okay, so if we take the first set, which is the first 10 numbers, and find the median of it, we're going to be looking between 5 and 6 right here, which in this case is 15 and 15, so the Q1 is going to be 15. There's the median. We do the same thing with the second half of data from 25 to 85. We go over 1, 2, 3, 4, 5. It's between the fifth and the sixth one right here in the second half, which is 42 and a half in this case. So Q1 is 15, Q3 is 42 and a half. So IQR, we subtract those, we get 27 and a half minutes. And we can interpret that. We say the range of the middle half of travel times for the New Yorkers in the sample is 27 and a half minutes. That's how you say that, the range of the middle half of the travel times. All right, so the last thing we're going to look at today with this video, in addition to serving as a measure of spread, the interquartile range, IQR, is used as part of a rule of thumb for identifying outliers. The 1.5 IQR rule for outliers. This is what we're looking at. So call an observation an outlier if it falls more than 1.5 IQR above the third quartile or below the first quartile. So we find the IQR, the interquartile range, we take times 1.5 and we look for how much, we add that to the third quartile and we subtract it from the first quartile, and if we have values above that or below this, we end up with, we consider those to be outliers. So for example, in our New York travel time data, we found Q1 to be 15 and Q3 to be 42 and a half. The IQR is 27 and a half. So our 1.5 IQR is 41.25. Now, we take Q1 minus this, which gives us a negative value. Okay, that's not practical in terms of this problem because you're not going to have a negative travel time. Oh, I've already I arrived there before I got there, before I even set out. No, that doesn't happen. So you take and try with your Q3. You add 1.5 IQR. That's 42 and a half plus 41.25, which comes out to be 83.75. Sorry, 83.75. Look to see if there's any travel time shorter than negative 26.25, which there isn't. That doesn't make sense in the problem, or longer than 83.75 minutes, and we consider those outliers. 85 is bigger than 83.75, so it is an outlier by this rule. Okay, by this rule, that comes out to be an outlier. All right. Finally, for today, we're going to look at the 5-number summary. So this will be our last slide for today. The 5-number summary is basically, you got your minimum value and maximum value. They tell us about how the distribution as a whole, what's it going from, the minimum to the maximum. And then you look at your Q1 and your median and your Q3. So the quartiles, the median and the quartiles tell us little about the tails of a distribution. So that's why it's important to have those minimums and maximums. To get a quick summary of both center and spread, we can use the 5-number summary. And that 5-number summary of a distribution consists of the smallest observation, the acute first quartile, the median, the third quartile, and the largest observation, written in an order from smallest to largest. That's the 5-number summary. And that's where we're going to stop for right now.